everybody, this is Dr. Nigra with the Chem Calculation Screencast. This screencast is going to focus on skill building in the area of naming and writing formulas for covalent compounds. If you need assistance with ionic compounds or acids, hydrates, or simple organic molecules, please make sure you go look at those specific videos, as that will not be covered here. All right, so as with the other compound types, we have to be able to identify a particular compound, formula, or name as covalent. All right, so the first key that we have a covalent compound is that all the elements are nonmetals. All right, so we shouldn't see any of the elements on the majority of the table. They should all be coming from that upper right corner of the periodic table. The other thing to keep in mind is it doesn't start with hydrogen. And, whoops, have an, whoops, that should be aqueous state. And you might ask, well, why? Hydrogen is a nonmetal. Well, if you have a compound that starts with a hydrogen and is in the aqueous state, that's going to be an acid. And they have different naming rules, all right? So if you see a hydrogen out front and it's not in the aqueous state, then you may have a covalent compound. But if it's in its aqueous state, that's going to be an acid, all right? Covalent compounds are actually much easier to handle in terms of names and formula writing because of the way these covalent compounds are formed, all right? Covalent bonds, which are inside of our molecule, form from sharing those electrons, not transferring, all right, which is reasonable because the elements that make up these compounds are all nonmetals. Nonmetals are more than willing to accept electrons if there's a metal willing to transfer them, but they are not willing to give away or donate electrons. So if you have a nonmetal with a nonmetal, neither one wants to donate an electron. So that means their only option then is to share electrons. So no transferring electrons. And what does that mean? It means no ions. All right, all of our atoms here are neutral. All right, now we will learn later in our bonding unit that sharing can be unequal between the two, in that the electrons reside closer to one atom than the other. So we do get a little bit of charge. We call that polarity, but we're not going to get into that today. The key point for us, covalent molecules form because electrons are shared between the atoms, which means that there's no ion formation. All right, so no charges. All right, and that also means no crisscross rules. So that means we have to have another way to designate the number of atoms that need to be present. Before we would use the crisscross rule, we would use the idea that the molecule has to be neutral to determine the number of positive and negative charges, which would in turn tell us the amount of ions we need. We don't have that option here. They're sharing electrons, there's no charges. So instead, we need to use, in the name at least, we're going to be using prefixes, all right? And in the formula, it's just going to have to be given to you, all right? There's no way for you to guess what the formula should be unless you're given the name, all right? Or you can calculate it mathematically, all right? Now, the prefixes that we're going to be using, we're going to need to know 1 through 10. So 1, 2, 3, 4, 7, 8, 9, and 10. All right, the prefixes should seem familiar. All right, so if we have one atom within a molecule, we're going to use the prefix mono. If we have 2, we use di. 3 is tri. Now 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8, whoops, let me just put that backwards, is octa. 9 is nona. And 10 is deca. All right, so similar to our polyatomics, you just need to know what these prefixes are. All right, some of them are pretty straightforward, di, tri, but some of them are a little new. Tetra might be a strange one for you. A lot of people like to use quadra, but it's tetra. All right, 7, hepta, that's a little funny. People like to use septa there, but it's hepta. All right, All right, so we're going to need those. We're going to use them if given the name, or we're going to use them to write the name. All right, so let's start with writing the name from the formula. All right, so if we're given the formula, we're going to use the subscript next to an element to determine what the prefix should be for the name of that element. And then for our second element, we're going to use its subscript, and then we're going to take the root of that element's name and switch the ending to IDE. All right, so again, prefix for the number atoms of the first element, and then the first element's name. Now, one thing to keep in mind here, if it's one, we do not use mono at the very beginning of any covalent name. So you're never going to see mono carbon, mono dioxide. All right, we would just say carbon monoxide. All right, now for the second element, the prefix for the number of the second element, then take the root and add that IDE ending. Okay, now what about if we're going the other way, writing the formula from the name? All right, so what we're going to do first is look at the first word in the name, and we're going to write the symbol for that element, and then we're going to take the prefix in front of that name, and we're going to use that as the subscript. All right, well, you won't have it for the first one. If there's no prefix at all, then we can assume there's one of those. All right, we never write ones as subscripts, we just leave it blank. All right, then we look at the second word and we write the symbol for the second element, and then we write the prefix number that matches, or we take the prefix number to write for the substrate. All right, now one thing to keep in mind, all right, we're going to write the elements in order listed by the name. All right, so in other words, if the first word is carbon, then that should be the first element in our formula. All right, keep in mind no charges, and that means no crisscross. All right, whatever the subscript is in the formula, that is the prefix for that element. Do not take the subscript of one element and make it the prefix of the other. Do not crisscross. All right, so let's start with our first one. So it looks like we have a name. So we have di, that tells me 2 nitrogen, so N2, and then tetra, so that's 4 oxide, that's oxygen, O4. All right, oh, and this is a great point. Do not simplify these formulas. All right, again, because these atoms are being put together through sharing of electrons, you have to have the number that is listed in the name. All right, there's no simpler way to put that compound together. It's not like charges where there might be a simpler way to do it. These are as is, so don't change anything. All right, so dinitrogen tetroxide is N2O4. All right, let's move on to our next one, sulfur. All right, please note no prefix out front, so that means 1 sulfur. And then we have hexa, so that's 6, and then bromide, so Br6. All right, boron, no prefix out front, so 1, and then 3 fluoride, so this is Bf3. All right, and then silicon, again, nothing out front, so 1 silicon, and then tetra, that's a 4, so SiCl4 for silicon tetrachloride. Okay, so again, no simplification, and make sure whatever the prefix is in front of the element, that is the subscript for that element. Do not crisscross. All right, next we have SbF5. All right, so if we look, we have 1 antimony and we have 5 fluorine. So this is going to be antimony, 5 is pentafluoride with that IDE ending. All right, so antimony, pentafluoride. All right, next we have krypton. So we have 1 of those, and then we have 4 chlorine, so that's tetra. So we have krypton, tetra, whoops, not fluoride, chloride. Krypton tetrachloride. All right, CO. So we've got one carbon and one oxygen. So again, no mono out front, just carbon. And then we are going to use monoxide. All right, probably have all heard of that, carbon monoxide. All right, SO3. So one sulfur and three oxygens. This is sulfur trioxide. Now, some of you, if you've been practicing your polyatomics, may say to yourself, oh, that's sulfite. All right, it is not. There is no charge here. So this is not a polyatomic ion. This is a covalent molecule, which has one less electron than sulfite. So this is sulfur trioxide, not sulfite. Sulfite would have a -1 charge, and we do not see that here. All right, that happens quite a bit. NO2, NO3, be careful. All right, do not mix and match covalent and ionic. All right, and then last we have antimony pentaiodide. All right, so antimony, there's no prefix, so 1. Then we've got penta, that's going to be 5, and then iodide tells me iodine. So antimony is SB, I5. Okay, so you can see that for covalent molecules, the naming and formula writing is actually much easier than ionic compounds or acids, right? But you have to know the prefixes, and you have to be very careful that you do not cross prefixes and subscripts. Okay?